Unit 2 is a higher scoring unit for just about every single student that I have ever taught. Unit 1, it is a secret among all the calculus teachers. God, in general, we don't like teaching Unit 1. All of the limits, we're like, why don't they remember limits from pre-calculus? Why, God, why? I don't know. I don't know what's wrong with your brains. I also know we do a lot with asymptotes and all the things, and at some point it just gets all jumbled up inside. Unit 1 is rough. Unit 1 test grades tend to be low. Unit 2 grades tend to be higher, I think, because you learn a lot in Unit 1, you learn a lot about how to study, all the things. Unit 2, it's all about the derivative. That's it, the derivative. We're going to get introduced to the first derivative, the second derivative, and something called the antiderivative. They are completely different functions, not the Antichrist, the antiderivative. There's 4 different functions. We're going to figure them all out. Life is good. Sylvia, life is good. In about 10 minutes, shortcuts are going to rain down from the sky. Sylvia, all the shortcuts become legal 10 minutes from now. 10 minutes from now.
What about the correction?
During corrections, no. No. Because here's what I need you to know. When I say go find the derivative, there's a formula. The formula that you need to know. I need to get some new markers today. The formula for the derivative, if I say, oh my God, really? Okay, take 3. Hey, that one works. If I say go find the derivative, that means find the limit as h approaches 0, f of x plus h minus f of x all over h. This is your definition of the derivative. It just is. It means slope of the tangent line at every single point. There are shortcuts, there are processes, Diego, that are coming your way that are going to make this process faster. But Gerson, you need to know if I ever say, hey, go find the limit as h approaches 0, f of x plus h minus f of x all over h. What am I really asking you to do? Find the derivative. It just means find the derivative. Gerardo, you okay? Okay, so here we go. This is the last time I'm going to ask you guys to do this for a while. You're going to evaluate some of these functions. You're going to find the derivative using the definition of the derivative. Now, those of you that want like a nice comfortable problem, okay, number 1, Sylvia's group, you guys are going to start with number 1. Number 2, Jesus' group, you guys have number 2. Number 3, that's going to be Paul's group. Marilyn, I have high expectations for you and everybody that sits with you. You guys have number 4. I have really high expectations for these folks up front. You guys are going to do number 5. I'm not going to say good luck. I'm going to say enjoy the ride. Do the best that you can. You've got a couple of minutes. There's some workspace down at the bottom. If anyone finishes early and you want more of a challenge, try number 6 or number 7. We're doing this little exploration so that you can see some things. Okay, and Karina, can you move the camera to over here?
Mister, I'm a sad panda.
Okay, so
You know how x minus 1? Oh, x minus 1.
Okay, Karina, everybody can see from over here?
Yes.
Alright, so I'm going to work through a tough one. Limit as h approaches 0, f of x plus h minus f of x all over h. Limit f of x plus h means 1 over x plus h squared minus f of x is 1 over x squared over h. If I try evaluating at 0, I'm going to get 1 over x squared minus 1 over x squared over 0, 0, 0. That's a bump. Okay. Everybody's working on their assigned functions. Okay. What I'm seeing here is I'm seeing these two fractions. I'm going to get a common denominator. x plus h squared, I'm going to multiply this first guy by x squared over x squared. I'm going to multiply the next one by x plus h squared over x plus h squared. Limit h approaches 0. X squared in the numerator minus x plus h squared in the denominator over here. In the denominator, x squared, x plus h squared, all over h. Whew. Ugly stuff. But here are some things I can do. X squared minus all this x plus h squared, I want to clean this up. I'm going to make this the limit as h approaches 0. X squared minus x plus h squared. X plus h times x plus h means x squared 2xh plus h squared. All that is divided by x squared, x plus h squared. This whole fraction is divided by h. That's the same thing as saying this fraction times 1 over h. Ugly, but we're going to get there. No, you're working on yours. I'm just working on a challenge problem. All right, other things I can do. X squared minus all this, I'm going to distribute the negative. X squared minus x squared minus 2xh minus h squared. X squared and the negative x squared cancel. That leaves me with the limit as h approaches 0 of negative 2xh negative h squared x squared x plus h squared times 1 over h. All the folks working on your assigned problems, I'll be ready to catch up with you in like 2 minutes. Still a whole lot of mess. What I see though in the numerator is a negative 2xh minus h squared. There's an h and there's an h. And hey, good news, there's an h down here. I'm going to factor out an h, which leaves me negative 2x minus h. The h up here and the h down there cancel. So now when I take the limit as h approaches 0 of negative 2xh minus h squared over x squared times x plus h squared, let go. My bad. Negative 2x and negative h. Take the limit as h goes to 0. That part's 0. This guy over here goes to 0. In the numerator, I've got negative 2x. In the denominator, I've got x squared times x squared. That's negative 2x over x squared, which simplifies to negative 2 over x cubed. The derivative is negative 2 over x cubed, Jeanette.
Really, boy?
No, you don't do that.
I got 1 over x.
Oh, it's a square. Yeah, boy.
All right, friends, time to pull it together.
What do you think? The show wasn't good enough, so I had to cancel that, right?
Oh, no.
You don't know how to do this, but you do.
All right, group number 1. Henry, that was your group, right? What did you guys get for your derivative?
I messed up.
Okay, but there's 2 other brains working there. What did you guys get for your derivative? Okay, my time's getting wasted here. Number 2, is that you guys?
Yeah, that's. Oh, yeah.
Oh, wait, I'm 1.
What do we get for the derivative?
Oh, we haven't finished.
Okay, number 3. Is that you guys? What'd you get? Okay, the derivative is 4x cubed. which means you guys must have done like a box that became a big box that became a really big box to work with x plus h to the fourth power. Or you could have done a shortcut, but this was not what the point was. The point was to use the definition of the derivative, just like I did over here, to get to this answer. This is still skills that you need to possess. Okay, group number 4. Was that you guys? What did you get?
1 over 2 radical x.
1 over 2 radical x. Perfect. Could not have asked for better. Perfect. Number 5, that was you guys up front?
We got 1 over x squared.
1 over x squared. I disagree with 1 over x squared. You're close. I disagree with 1 over x squared. What did you guys get?
1 over 2.
For number 5?
Okay, never mind.
Okay, I'm not sure where you guys went wrong, but the answer should have been negative 1 over x squared. Number 6, I worked with 1 over x squared, and the answer came out to be negative 2 over x cubed. Looping back around to groups 1 and group 2 that just had some extra time. Did we finish off number 1? Okay, have we finished off number 2 in the back? What'd you get?
3x squared.
3x squared. Plus 1. The first one, had that been done correctly, you would have 6x minus 5. Here is my goal. My goal is in the next 21 minutes to get you guys to the point where you can find all of these derivatives, all 7 of these derivatives, in about 2 minutes or less. This is the goal, and this is a very realistic goal. There are some patterns that are happening here, some patterns that you may have already known before coming in because last year's calculus class told you, or because you discovered some things in pre-calculus. How many of you all are pretty sure you know some shortcuts, some ways to make your life better? Either you already know them or you're looking at the answers up here in the derivative column and you're making some connections. I see 1. I see 2. Talk to the friends around you. What connections, if any, are you making? Especially look at 1, 2, and 3. What connections are there?
Then on the bottom, that one and then you bring this one down.
I need a note. Hey, Karina, are we filming over here now? Okay, so where are the friends that think they know the shortcut? Matt, 1, 2, 3, maybe 4 people, 5 people. How many of you would like to know a shortcut that's going to make your life a lot faster, a lot better? Okay, moving on. This whole next page, these are the derivative rules. These are things that are here to make your life better. And we're going to flip back over to page number 4 so you can actually see that I'm not lying to you all. As some people might think that I do. All right, can I get Jesus? Can you read what's called the power rule, please?
If f of x equals x to n power, then f prime of x equals n of x to the n minus 1 power. Note, this rule works for all values of n, not just integers.
Okay, the power rule is when you have x raised to a power. X to the 4th power, x to the 5th power. The way that you find the derivative of x to a power is going to be n times x to the n minus 1. I want you guys to say this with me, please. When taking the derivative of x to a power,
When taking the derivative of x to a power,
we bring the power down
We bring the power down
and reduce the power by 1.
and reduce the power by 1.
Okay, now I want to make this a little bit stickier. Okay. Here's what the power rule says. When I have x
When I have x
raised to a power,
raised to a power,
what do we do to find the derivative? Bring the power down.
bring the power down
And reduce the power by 1.
And reduce the power by 1.
Okay, one more time. Power rule says,
Power rule says,
if I have x,
if I have x
raised to a power,
raised to a power,
what do we do?
bring the power
down and reduce the power by 1. So let's see if we actually have any evidence. Go back to page 4. Do we have any evidence that this actually is a thing? That I'm not lying to you? Unfortunately, all of mine are gone. What was the derivative of x to the 4th?
4x
The derivative of x to the 4th is 4x cubed. X to the 4th, so this is x to a power, right? The power rule says bring that power down, and then what?
Reduce it by 1.
Reduce the power by 1. So the derivative of x to the 4th is 4x cubed. Now, I think I also told you that the derivative, or you guys told me, that the derivative of 1 over x, what was the derivative over here? Negative 1 over x squared. Let's see if the power rule works here. Is this a power rule problem? Is this x raised to a power? It is. If you think like an Algebra 2 student, it is. Algebra 2 students are really good with exponent rules. They know some stuff. They know that there's a way to rewrite 1 over x using exponents. Daisy?
Is it? It's gonna the x is x negative 1.
1 over x is the same as x to the negative 1 power. This is not the derivative. This is a way to rewrite this. Does everybody see it as x to a power now?
Yes.
Okay, well, what's the derivative? What does the power rule say? The power rule says bring the power down, and then what? Reduce by 1, which means subtract 1. Check it out. Negative 1 minus 1 is negative 2. X to the negative 2 is the same as saying negative 1 over x squared. That's using the power rule instead of the definition of the derivative. Life is good. Life just got way quick. Way quick. So let's look at a couple of examples here back on page 5. Because remember, we've got all sorts of different notations that I'm going to use here. So if I wanted to find the derivative of x to the 100, take like 5 seconds. Go find the derivative. Raise your hand when you think you got it. Thanks. Okay, I see 1. I see 2. I see 3. I see 4. Jeanette, coming at you. What's the derivative?
X to the 99 5?
Not x to the 99. I disagree. Sylvia, what's the derivative?
100x to the 99?
Y prime, the derivative, remember we bring the power down and then we reduce the power by 1. So 100x to the 99th power. Jeanette, are you okay?
Yeah.
You had the x to the 99, but you forget about the 100. Everybody else, we're doing okay? Yeah. Yvel, what's up?
For an equation that has more than one x.
Oh, hold that thought. Hold that thought. Hold that thought. So what about this example number 2? F of x is 1 over x squared. This says d dx. What does d dx mean? Derivative. So I want you to find the derivative of f of x. F of x is 1 over x squared. Is that a power rule?
Yeah.
If it is, that's because you know some stuff here. How am I going to rewrite, Jesus? How am I going to rewrite 1 over x squared so I can use my power rule?
X to the negative 2.
X to the negative 2. Now, I want to be careful with my notation. This isn't the derivative yet. This is just some algebra. I'm rewriting. Diego, what does that power rule tell me to do?
Bring it down.
Bring what down? Bring it down sounds kind of, you know. Bring the exponent down. Reduce the power by 1. So what do we get here? Reduce by 1. Negative 2x to the negative 3. Now, negative 2x to the negative 3, that's a good answer. That's a good answer. I'm not going to disagree with negative 2x to the negative 3rd. But there's a better answer. Michelle, do you get a better answer for me? Negative 2x to the negative 3, that's good. But you've got some algebra skills. A better answer. Jalissa wants to help out here. Karina wants to help out here. Marilyn wants to help out here. Michelle, if you're not sure, and it's okay. Okay, think about negative exponents. Marilyn, help her out.
It's negative 2x cubed.
Negative 2x3
Over.
over x to the third. Which one of these is correct? Both. Okay? On a free response, I'd probably stop here, but on the multiple choice, this is how they're going to hide it from you. All right, I want you to take a minute with the friends that are around you. Try 3 and 4. These are tricky. You know me. Tricky. The power rule says bring that power down and then reduce the power by 1. Negative 9 minus 1. Okay, so exponent rule, if I have 1 over x to a power, like x squared, that is the same as saying x to the okay. Oh, I'm seeing some good stuff here. Oh, there's a proud Algebra 2 teacher. Most folks have rewritten square root of x as x to the 1/2 power. Now, notation, be careful. J prime, bring that power down. Reduce the power by 1. That might be a 2-step kind of process. 1/2 minus 1 is not negative 3 over 2. 1/2 minus 1 is the same as 1/2 minus 2/2.
Negative 1/2.
Which is negative 1/2. I love this answer. This is a good, solid answer. But not the way I'm going to write it on the multiple choice. I'm going to hide it. Anybody know how I'm going to hide this from you? Oh, I'm going to hide this sucker. What you got, Flora?
1 over 2 square root of x.
It's the same as 1 over 2 times the square root of x. Sylvia, that negative exponent says send it to the denominator. So where it would become x to the 1/2, but x to the 1/2 is the same as square root of x. Okay. This is a great answer. That's a great answer. I'll take them both. Now, I saw some folks getting kind of confused with example number 4 here. Derivative of x?
Yeah.
Is that a power rule? We only know one derivative shortcut here. And this is for powers. Is this, Sheila, do you see this as x to a power? No? Thank you for your honesty. Somebody help her out. Or did you say 1? You said 1. Okay, now be careful. I'm still writing this d dx. X is the same as x to the 1, right? Mathematicians, we're lazy. We don't like to write that 1. Power rule. What does the power rule say?
1 times x to the power of 0.
It says bring that power down
Yes.
and reduce the power by 1. And x to the 0?
1. I mean, no.
No, it actually is 1. Stop contradicting yourself. Okay? The power rule is not too bad. Bring the power down, reduce the power by 1. We get that. We got that. But it's all the algebra trickery things that are going to happen that are going to mess with your brain. And you need to be ready. Okay, well that's one of the rules. We got like 3 more.
Yeah.
Oh, Andy, you got this. Andy, you got this one. Can you read the next one?
The derivative of a constant is 0. However, if y equals c times f of x, then the
Derivative, yeah.
c f of x prime, where c is a constant.
Okay, say it like you mean it. The derivative of a constant is 0.
The derivative.
The derivative.
Oh, come on, say it with attitude. Say it like your grade depends on it.
The derivative of a constant is 0. However, the derivative of y equals
Constant times
The function is equal to the constant times the derivative of the function.
Good thing your grade didn't depend on that. Okay, so here we go. I would hope everyone's like, hey, wait a second. What's the derivative of x squared? We know this now. We have skills. Derivative of x squared? The derivative of x squared
2x.
is 2x. That's the power rule. But this is a constant. 3 is a constant times a function. And the power rule says it's just going to be the constant times the derivative. So 3 times 2x, which is going to be 6x. Okay, let's look at example number 6. For f of x equals 5 times x to the 12th, oh, there's that constant again.
That's it?
Uh-huh.
The first one?
Yeah, that was it. You blinked, you missed it. You're bad. Okay. Find f. Oh my God, what is that?
60.
60
Know that notation?
Oh my god.
F prime prime? F double prime? Trust your instincts here. What does F double prime mean?
Times 2?
Not times 2.
Is the
Not divide. It's the derivative
of a derivative?
of the derivative.
Oh.
It's not the anti. That's coming later, Henry. Don't be absent that day. The derivative of the derivative. Okay, well, let's see what we can do here. What's F prime?
60x. 60x.
I'm going to write it
60x to
this
the
way.
power.
5 times 12x to the 11th, right? I want to see that constant rule. And everyone's already like, oh, 60x to the 11th. Great. Now go get F double prime. The derivative of 60x to the 11th is 60.
Wait,
11x to the 10th. And if you really want to show off for the friends at home, 660 x to the 10th. And guess what? If we can find F double prime, there is no stopping us. There's no stopping. You can find F triple prime, F quadruple prime. My calculus BC friends, we are going to take an infinite number of derivatives at some point.
Are we going to do that?
No. No, your brains are smaller.
What is an
The antiderivative, you go backwards. Okay, last one. Here come the last couple of rules. Here we go. Here we go. Okay, sum and difference rules. This was Evel's question. Evel, your question was like, what if you have multiple things going on? Jeanette, what's
Why
up?
would we need to find the derivative of the derivative? Like in a real world situation.
Oh, these things don't exist in the real world. I just make this up. Jeanette, we are going to get to the real world. We're going to look at particle motion. We're going to look at physics, all the things. Andy, don't make that face at me. Life is good. We're going to spend a whole unit on the applications, just Jeanette, because you said so.
No.
Okay.
Thanks, Jeanette.
All right, friends. Back to me. Sum and difference rules. Sum and difference rules just say this. If you have a whole bunch of things being added together and you want to find the derivative, take the derivative of each part and add those together. It's the way Sylvia would define this if she wanted to. All right, so here we go. F of x is equal to x cubed plus x minus 1. I want to find f prime of negative 1. F prime of negative 1 is a two-step process. Number 1, we're going to find f prime. Number 2, we're going to evaluate at x equals negative 1. So let's do it. I need f prime of x. Take a minute. Be ready to talk to me about what f prime of x is. F of x equals x cubed plus x minus 1. Raise your hand when you think you've got f prime of x. I see 1, I see 2, I see 3.
What does 2 say?
2 says evaluate at x equals negative 1. First you find the derivative, then you plug in. I see 5, I see 6. Karina, what do you got for me?
3x squared plus
3x squared, right? Because the derivative of x cubed, bring the power down and reduce the power by 1. Plus
1,
the derivative of x,
1,
1, minus the derivative of 1
0.
is 0. Guess what? That's f prime of x. Now get f prime of negative 1. 3 times negative 1 squared plus 1 should be 4. Done. Easy peasy. Easy peasy lemon squeezy.
So when you find a derivative using that method, you just ignore the numbers that don't have a x on them?
Okay, first of all, the number that don't have an x on it, we're going to call it constant. Okay? And the derivative of a constant is 0. Constants are not changing. Okay. All right. Example number 8. Show me what you can do. Oh, I can't wait to see what you guys do with this one. I have faith. Faith enough for 4. Yeah, we're going to talk about that in a minute. I want to see good notation. Yeah.
So you know how the 1 drops down?
Uh-huh. X to the 7. If I take the derivative, you bring the power down in front, which is 1 times x to the 0. Anything to the power of 0 is 1.
Minus 1.
Yes, good. Give me a second, give me a second, give me a second.
Whatever it is.
The derivative of x is 1. That's what we did up in example number 4.
Minus 1.
Oh, sadness. So sorry. All right, a couple of notational things here, friends. You are not... Henry, hold on. I am not asking you to find f prime of x.
No, F prime of t.
It's f prime of t. T is your independent variable. Okay, f prime of t. Derivative of t to the 8th, everybody's going to tell me is?
8
t to the 7th power. Plus the derivative of t squared?
2t.
2t. Plus the derivative of e?
1.
Not 1. 0.
2.
What do we know about e? E is a constant. E is approximately 2.71828 and some change. What's the derivative of e?
0.
0. So f prime of t is 8t to the 7th plus 2t. F prime of negative 1 is 8 times negative 1 to the 7th plus 2 times negative 1, which is negative 8 minus 2, which is negative 10. How many guys honestly came up with negative 10? Okay, got a couple of folks kind of sprinkled throughout the room. Okay, if we had a little bit more time, there are some practice problems on page 6. Okay? Remember the conversation we were having about the more that it's going to take to be successful?
Yes, sir.
This is not homework. I would strongly encourage you tonight to get these problems done. Hold on. What you guys need to do is start on those test corrections and the reflection. That is due Friday. That's the what you have to do. This is the more because you care about your grade going up. That wasn't for you guys. Okay. Thanks, sir. All right. Sir, you get one of these.